August 4th, 1942. The Henschel factory floor in Kassel, Germany. Workers guide the first production Tiger tank off the assembly line. 57 tons of rolled nickel steel armor, powered by a 700 horsepower Maybach engine, mounting the feared 88mm gun that could penetrate any Allied tank at combat ranges. The factory managers record the statistics with pride. 300,000 man-hours, 250,000 Reichsmarks, a weapon that would strike terror into enemy tank crews from Tunisia to Normandy. What they don't record is the hidden cost. The steel consumed by this single Tiger could have built 21 105mm howitzers. The labour could have produced thousands of rifles. The brass and copper in its electrical systems could have been pressed into millions of cartridge cases. Over the next 2 years, Henschel will build 1,347 Tiger tanks. Another factory will add 492 Tiger II heavy tanks. By war's end, Germany will have produced 1,839 of these technological marvels at a combined cost that defies rational calculation. This is the story of an industrial choice that would help seal Germany's fate. Not the choice to build the Tiger itself, but the choice to build it instead of something far more fundamental to modern warfare: ammunition. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The German obsession with technical superiority didn't begin with the Tiger. It emerged from a doctrine forged in the trenches of the First World War and refined during the interwar years when Germany was forbidden from maintaining large armies. Unable to match potential enemies in quantity, German military theorists convinced themselves that quality could substitute for numbers. Superior training, better tactics, and more advanced weapons would multiply the effectiveness of each soldier and each machine. This philosophy produced genuine innovations: the panzer tactics that shattered Poland and France, the combined arms coordination that defined blitzkrieg, the 88mm flak gun that proved equally devastating against tanks and aircraft. But by 1942, as the Wehrmacht bled in Russia and the industrial might of America entered the war, this doctrine was colliding with a brutal mathematical reality. Wars are not won by the best weapons. They are won by enough weapons. The Tiger program embodied everything brilliant and fatal about German armaments philosophy. When Soviet T-34 tanks began shredding Panzer III and IV formations on the Eastern Front in 1941, German commanders demanded a response. The T-34's sloped armour deflected German tank rounds at combat ranges. Its 76mm gun punched through German armour like paper. Its wide tracks and diesel engine gave it mobility German tanks couldn't match. Hitler personally ordered the development of a heavy tank that could dominate the battlefield. 2 companies competed for the contract. Ferdinand Porsche submitted an innovative design with electric drive. Henschel proposed a more conventional but buildable tank. The Waffenamt, Germany's weapons development agency, debated for months. Engineering committees argued over armour slopes, gun mantlets, suspension systems. Hitler himself weighed in on turret dimensions. The deliberations stretched from late 1941 into early 1942, 8 months consumed by pursuit of the perfect design. When Henschel's Tiger finally entered production in August 1942, it represented the pinnacle of German engineering: rolled homogeneous nickel-steel armour with Brinell hardness of 255 to 280. The highest quality armour plating any nation produced during the war. Frontal armour, 100mm thick, could withstand direct hits from most Allied anti-tank weapons. Side armour, 80mm thick, provided protection few tanks could match. The total weight approached 57 tons, requiring tracks 725mm wide just to distribute the mass. The main gun was the 88mm KWK 36L56, derived from Germany's famous anti-aircraft gun. At 1,400 metres, it could penetrate 112mm of armour. No Allied tank fielded in 1942 could survive a frontal hit. British crews testing a captured Tiger in Tunisia reported with dismay that only their largest anti-tank guns posed any threat. The combination of impenetrable armor and devastating firepower made the Tiger seemingly invincible in direct combat. But invincibility came at a cost that went far beyond money. The Tiger's complexity required specialized manufacturing. The interleaved road wheel suspension, designed for superior cross-country performance, demanded precision machining that slowed production to a crawl. Each wheel had to be individually fitted. The overlapping design meant that replacing a damaged inner wheel required removing multiple outer wheels first. Field mechanics learned to hate the system, especially in Russian mud and winter ice where the wheels would freeze solid. The Maybach engine, producing 700 horsepower to push 57 tons, was a marvel of engineering and a nightmare to manufacture. Cylinder blocks frequently cracked during casting. Crankshafts failed quality control. Delivery schedules slipped month after month as suppliers struggled to meet the exacting tolerances. The dual-radius transmission, sophisticated beyond anything in other tanks, broke down constantly in early production models. Replacement transmissions didn't exist in forward supply depots. Production began at 25 Tigers per month. The Henschel factory, which had built locomotives before the war, retooled entirely for Tiger production. One floor, one assembly line. Peak production reached 104 tanks in April 1944. Compare that to American Sherman production. One factory, the Chrysler Detroit Arsenal, built 200 Shermans monthly by mid-1942. Multiple American factories, 11 in total, produced Shermans using standardized parts and mass production techniques borrowed from automotive manufacturing. The Sherman could be assembled in 10 hours. The Tiger required 300,000 man-hours from start to finish. That figure includes not just final assembly, but the entire supply chain. Steel mills rolling armor plate, machine shops cutting gears, electronics firms building radio equipment. Every Tiger absorbed resources on a scale that defied industrial logic. Consider what 300,000 man-hours actually means. If you could employ one worker, full-time, that equals 150 years of labor. For a single tank, the Henschel factory needed thousands of workers operating simultaneously to achieve even modest production numbers. Many were skilled craftsmen whose expertise could have been applied elsewhere. Others were forced laborers from occupied territories, adding moral horror to industrial inefficiency. The cost in Reichsmarks, 250,000 per Tiger, exceeded a Panzer IV by more than double. It cost 4 times as much as a Stug 3 assault gun, but monetary cost understates the real price. Germany didn't have unlimited money, but it had even less access to critical materials. By 1943, Allied bombing and territorial losses were strangling Germany's supply of copper, nickel, chrome, and other strategic metals essential for advanced weapons production. Every Tiger consumed these scarce materials in quantities that could have equipped dozens of simpler weapons. The electrical system alone required copper wiring that could have been pressed into thousands of cartridge cases for rifle ammunition. The nickel-steel armor, while superior in quality, absorbed nickel desperately needed for other purposes. The roller bearings in the transmission and road wheels required chrome steel increasingly difficult to obtain, but the most critical resource the Tiger consumed was steel, raw, basic steel, the building block of all industrial warfare. A single Tiger used enough steel to build 21 105mm howitzers. That's not a metaphor. German accountants calculated the steel weight and compared it to artillery production figures. One tank, or 21 artillery pieces that could rain high-explosive shells on enemy positions from kilometers away. The arithmetic gets more disturbing when you calculate total Tiger production. 1,839 Tigers, combining the Tiger 1 and Tiger 2 models. If we use the figure for Tiger 1s, which comprised the vast majority, we're looking at approximately 1,347 tanks, weighing roughly 57 tons each. That's 76,000 tons of steel locked up in heavily armored vehicles that frequently broke down before reaching the battlefield. 76,000 tons of steel. Germany's total steel production in 1942 was 32 million tons. By 1943, Allied bombing had reduced output to 30 million tons. By 1944, just 26 million tons. The Tigers consumed a tiny percentage of total production, perhaps 0.23%. But steel wasn't the constraint. The constraint was tool steel, specialized steel, and the manufacturing capacity to turn raw steel into precision components. Germany produced approximately 63,800 tanks and self-propelled guns during the entire war. The 1,839 Tigers represented less than 3% of total armored vehicle production. Yet they consumed disproportionate shares of the most advanced manufacturing capacity. The same factories that built Tigers could have built Panthers or Panzer IVs in larger numbers, using less demanding specifications. The real question isn't whether Tigers were effective in combat. They were devastatingly effective. Kill ratios of 10-1 or higher weren't uncommon. A well-positioned Tiger with a trained crew could dominate a battlefield, destroying enemy tanks at ranges where return fire posed little threat. The psychological impact was immense. Allied soldiers developed Tiger phobia, seeing Tigers everywhere even when facing inferior German tanks. British General Montgomery banned reports mentioning Tiger prowess to prevent panic among his forces. But effectiveness in individual combat means nothing if you can't field enough weapons to affect strategic outcomes. By mid-1944, Germany faced a crisis not of tank quality, but of tank availability. Soviet offensives in the east and Allied advances in the west were grinding through German armor faster than factories could replace losses, not because German tanks were inferior, but because there weren't enough of them. The Tiger program reveals a fundamental misunderstanding of industrial warfare that plagued German planning throughout the conflict. Military theorists focused on the tactical, the immediate battlefield where superior weapons proved their worth. They ignored the strategy, the long war where industrial capacity and resource availability determined victory. One Tiger might destroy 10 Shermans, but America could build 50 Shermans for every Tiger Germany produced, and America could keep building them faster than Germany could destroy them. This wasn't just a problem with tanks. The same logic infected German thinking across all weapons development. The Luftwaffe pursued advanced jet fighters when conventional fighters in larger numbers would have been more effective. The Kriegsmarine built massive battleships when U-boats in greater quantities might have starved Britain. Every program chased technical superiority while ignoring industrial reality. The ammunition crisis that would strangle German forces by 1944 wasn't an accident. It was the inevitable result of prioritizing complex weapons over basic supplies. Every ton of steel, every kilogram of copper, every hour of skilled labor devoted to Tigers was steel, copper, and labor not devoted to ammunition production. The Tigers' advocates would argue the tank's battlefield performance justified the investment. German records claim Tigers destroyed over 10,300 enemy tanks and 11,380 artillery pieces, for the loss of 1,725 Tigers. These numbers, if accurate, suggest remarkable effectiveness. But the records include all operational and strategic losses. Tigers abandoned due to mechanical failure. Tigers were blown up by their own crews because recovery was impossible. Tigers lost to Allied air attack while being transported by rail. The actual combat loss ratio, while impressive, couldn't overcome the fundamental mathematics of industrial warfare. By the autumn of 1943, German infantry divisions on the Eastern Front were reporting critical ammunition shortages. Artillery batteries rationed shells to 10 per day. Machine gunners received strict orders to fire only in short, controlled bursts. Rifle ammunition, the most basic supply required by every soldier, was becoming scarce in forward positions. Supply officers found themselves choosing between shipping, ammunition or replacement weapons, between boots or bullets, between medical supplies or motor fuel. This wasn't supposed to happen. Germany had entered the war with vast ammunition stockpiles built during the rearmament years of the 1930s. In 1941, during the initial invasion of the Soviet Union, German forces expended ammunition freely, confident that production would maintain supplies. But the Soviet Union didn't collapse as planned. The war stretched from weeks into months into years, and German ammunition production, for all its efficiency, couldn't keep pace with consumption. The problem wasn't just production capacity, it was resource allocation. The German Armaments Ministry, reorganized under Albert Speer in 1942, dramatically increased weapons production through rationalization and efficiency improvements. Tank production multiplied by a factor of 5 between 1940 and 1944. Artillery production tripled. But ammunition production never achieved proportional increases because the same factories, the same skilled workers, the same raw materials had to be shared across all programs. Steel that went into Tiger armor didn't go into artillery shells. Brass that went into electrical components. It didn't go into cartridge cases. The labor that assembled Tigers didn't fill ammunition boxes. The choices seemed reasonable at the time. Tigers were effective. They boosted morale. They demonstrated German technological superiority. But every choice has an opportunity cost, and in war, opportunity costs are measured in lives and territory lost. The 7.92mm Mauser rifle cartridge, the standard ammunition for German infantry throughout the war, represents everything the Tiger wasn't. Simple, mass-produced, individually insignificant, but collectively essential. Each round consisted of a brass case, copper jacket, lead core, steel penetrator in some variants, and propellant. The total weight per cartridge was approximately 21 grams. The cost per round in resources and labor was measured in pennies, not Reichsmarks. A soldier could carry 200 rounds easily. A supply truck could transport hundreds of thousands. Production lines could stamp out millions daily when materials were available. This was the ammunition that kept German infantry fighting from 1939 through 1945. 80% of combat on the Eastern Front was infantry fighting with rifles, machine guns, and grenades. Not tanks dueling at long range, not artillery barrages. Infantry, in close combat, where individual marksmanship and ammunition availability decided who lived and died. By 1944, German soldiers were being issued ammunition belts with 30 rounds instead of the standard 60. Some units in desperate defensive positions received orders to fix bayonets and conserve bullets for only the most critical moments. This wasn't defeatism or poor supply planning. This was mathematics. Germany didn't have enough brass, copper, and lead to produce ammunition in the quantities modern warfare demanded while simultaneously building Tigers and other complex weapons. The trade-off becomes stark when you calculate what the Tiger program cost in terms of ammunition production. One Tiger consumed approximately 57 tons of steel. But what about the other materials? The copper in electrical systems, the brass in fittings, the specialized alloys in the transmission and engine. The precise calculations are impossible because German records didn't track resources that way, but we can make reasonable estimates based on known component weights and material requirements. Consider just the steel, 76,000 tons tied up in 1,839 Tigers. A 7.92mm Mauser cartridge case requires approximately 11 grams of brass. But let's focus on steel, which went into bullets and cartridge production machinery. If we assume even a fraction of that Tiger steel went instead to ammunition production infrastructure, the numbers become staggering. This is where the title's claim comes from. Not that you could literally turn Tiger tanks into rifle rounds, but that the resources consumed by the Tiger program, if redirected to ammunition production, could have provided vastly more military value in the context of the war Germany was actually fighting. 90 million rifle rounds isn't hyperbole. It's conservative mathematics based on resource allocation during total war. But we're getting ahead of the story. First, we need to understand exactly how Germany reached the point where ammunition shortages threatened to paralyze entire armies, while Tigers sat immobilized by mechanical failures or lack of fuel. We need to examine the production systems, the supply chains, and the competing priorities that turned German armaments into a case study of how not to conduct industrial warfare. The ammunition shortage that crippled German forces by 1944 didn't emerge suddenly. It grew gradually, predictably, from decisions made years earlier about resource allocation and industrial priorities. The statistics tell a story of consumption outpacing production despite Herculean manufacturing efforts. German ammunition expenditure increased from 1,557 tons daily in 1942 to 2,453 tons in 1943. By 1944, daily consumption reached 2,941 tons, nearly double the 1942 rate. Production increased during this period, but never kept pace with battlefield consumption. The gap widened month by month. On the Eastern Front in 1941, ammunition expenditure for the first 6 months exceeded 8 million rounds for 105mm light field howitzers alone. Add mortar shells, anti-tank rounds, small arms ammunition, and the total weight of munitions consumed reached staggering levels. A panzer division at rest consumed 30 tons of supplies daily. In heavy combat, that figure jumped to 711 tons. An infantry division required over 1,000 tons daily during intense fighting. These numbers represent more than statistics. They represent the physical reality of industrial warfare. Every shell fired required steel, explosives, brass for fuses, and labor to assemble components. Every rifle cartridge needed brass cases, copper jackets, lead cores, and propellant. The raw materials came from mines, smelters, and chemical plants already stretched to capacity. The labor came from workers needed elsewhere in the war economy. The German ammunition industry performed remarkably under these pressures. Monthly rifle production increased from 133,000 in 1941 to 307,000 by November 1944. Machine gun production rose from 7,100 monthly to 28,700. These increases demonstrated effective industrial mobilization under Albert Speer's reorganization of armaments production. But weapons without ammunition are useless. Metal. Germany produced over 10 million rifles during the war, yet by 1944, frontline units were rationing ammunition to levels that compromised combat effectiveness. The St. G44 assault rifle, that revolutionary intermediate weapon, faced ammunition shortages so severe that planned monthly production of 200 million rounds proved impossible. Hitler's concerns about requiring 86,000 additional workers just to produce ammunition proved prophetic. Those workers didn't exist. The rifle and pistol ammunition production figures for 1943 show 3,174,000,000 rounds produced. Sounds impressive until you calculate consumption rates. With millions of soldiers on multiple fronts, each requiring training and combat ammunition, the supply never matched demand. Infantry units that should have trained with live fire practiced with blanks or not at all. Soldiers reached front lines with minimal marksmanship. Preparation. Artillery ammunition shortages became critical by late 1944. German forces on the Western Front averaged just over 12 rounds per day per 105mm howitzer during the Siegfried Line campaign. Compare that to American artillery doctrine, which assumed unlimited ammunition availability and emphasized massive fire support for infantry operations. German gunners watched helplessly as American artillery plastered their positions with sustained barrages they couldn't answer. The Ardennes offensive in December 1944 consumed 1,200 tons of ammunition daily. Planners had allocated supplies carefully, knowing no resupply would reach forward units. The Second Army possessed just 15,099 tons of ammunition at the offensive's start. They provided over 5,000 tons to the 15th Army. During the offensive's brief duration, ammunition shortages prevented exploitation of early successes. Artillery fell silent. Infantry attacks proceeded without fire support. The offensive stalled, partly because guns couldn't shoot. The ammunition crisis affected every weapon system. Anti-tank guns rationed rounds. Mortars fired sparingly. Even small arms ammunition became scarce in some sectors. By early 1945, some German units received orders to fix bayonets and conserve bullets for close range only. This wasn't panic or poor planning. This was mathematics. German production, despite increases, couldn't sustain the consumption rates of multi-front total war. The Tiger program's role in this crisis becomes clear when examining resource allocation. Every ton of steel, every kilogram of copper, every hour of skilled labor devoted to Tiger production was steel, copper, and labor not available for ammunition production. The trade-offs were explicit in planning documents but abstract to commanders who wanted more Tigers. Consider the production process for a single 7.92mm Mauser cartridge. The brass case required approximately 11 grams of brass, an alloy of copper and zinc. Germany's copper supplies came primarily from imports that Allied naval blockades disrupted. Domestic production couldn't meet demand. Every electrical fitting in a Tiger consumed copper that could have become thousands of cartridge cases. The bullet itself required a copper jacket, lead core, and in some armor-piercing variants, a steel penetrator. The propellant required chemical production capacity and ingredients, including nitrocellulose. The primer needed specialized chemicals and precise manufacturing. Each component represented a separate supply chain, a different factory, and multiple transportation steps. Multiply by billions of rounds, and the logistical complexity becomes staggering. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The copper constraint was particularly acute. Electrical systems in modern weapons consumed copper at rates that shocked pre-war planners. A Tiger tank contained hundreds of meters of copper wiring. The radio alone required copper components that could have produced several thousand cartridge cases. Multiply by 1,839 Tigers, and the copper consumption represented millions of foregone cartridges. But copper in Tigers was just part of the problem. German industrial strategy prioritized complex weapons across all services. The Luftwaffe pursued jet fighters that required exotic materials. The Kriegsmarine built U-boats with copper-rich electrical systems. The Heer developed self-propelled guns, tanks, and armored vehicles, each consuming copper in electrical systems, shell casings for their ammunition, and various fittings. The aggregate effect was a copper shortage that constrained ammunition production throughout the war. By 1944, Germany couldn't obtain enough copper to produce ammunition at rates needed to sustain operations. Substitutes existed. Steel cartridge cases could replace brass in some applications, but steel cases wore out rifle barrels faster and sometimes jammed in chambers. They were inferior substitutes for desperate times. The brass shortage extended beyond rifle ammunition. Artillery shells used brass in fuses, driving bands, and various components. Anti-aircraft ammunition required brass cases. Tank shells needed brass elements. Every weapons system competed for the same limited copper supplies. The Tiger program, consuming copper in quantities that exceeded simpler weapon systems, exacerbated shortages across the entire military. The labor constraint was equally severe. Manufacturing a Tiger required 300,000 man-hours. That included all supply chain labor, not just final assembly. Steel mills rolling armor plate, machine shops cutting gears, electronics firms building radios. Workers, at every stage, were skilled tradesmen whose expertise took years to develop. You couldn't replace them with unskilled labor without sacrificing quality. Ammunition production also required skilled labor, particularly for explosives filling and fuse assembly. But the skill levels weren't as specialized. Women and less skilled workers could perform many ammunition production tasks after brief training. The bottleneck wasn't worker capability, but raw material supply and factory capacity. Germany had factories. It lacked copper, lead, and chemicals. The choice between Tigers and ammunition wasn't explicit in any single decision. It emerged from accumulated priorities, from engineering culture that valued technical excellence, from doctrine that emphasized quality over quantity. Every meeting where officials allocated steel or copper or labor hours made implicit trade-offs. More resources to Tigers meant fewer resources elsewhere. Albert Speer's production miracle from 1942 through 1944 demonstrated what German industry could achieve with proper organization. Tank production multiplied, aircraft production soared, Artillery production tripled. These increases came from efficiency improvements, better resource allocation, longer working hours, and ruthless prioritization. But even Speer's rationalization couldn't overcome fundamental resource constraints. Germany's steel production peaked at 32 million tons in 1942. By 1944, Allied bombing and territorial losses had reduced output to 26 million tons annually. Every ton allocated to Tiger armor meant less steel for ammunition, production, infrastructure, for machine tools, for railway equipment needed to transport supplies. The allocation decisions had cascading effects throughout the war economy. The ammunition production system required more than raw materials. It needed specialized machinery for stamping cases, filling explosives, and assembling components. These machines required steel, precision parts, and skilled maintenance. They wore out from continuous operation. Replacing them required resources and time Germany couldn't spare. By 1944, ammunition factories were running equipment past its service life, accepting higher defect rates rather than stopping production for maintenance. The quality control problems this created affected combat effectiveness. Ammunition that misfired or failed to detonate wasted scarce resources. Soldiers learned to distrust certain lot numbers. Artillery crews watched duds land without exploding. Small arms shooters experienced jams from poorly manufactured cartridges. The degradation in quality partially offset increases in quantity. The Soviet Union faced similar resource constraints but made different choices. Soviet tank production emphasized simplicity and mass production. The T-34 used less specialized materials than German tanks. Its simpler construction required fewer man-hours. Soviet industry produced 57,000 T-34s during the war, nearly 30 times the number of Tigers Germany built. Soviet ammunition production prioritized quantity over perfection. Tolerances were looser. Quality control was less rigorous. But Soviet soldiers had ammunition when they needed it. Soviet artillery could sustain barrages that German forces couldn't answer. The crude but available defeated the excellent but scarce. American industry demonstrated yet another approach. American production emphasized both quantity and quality through standardization and mass production techniques. Sherman tanks used readily available materials and could be built quickly. American ammunition production reached such a scale that supply officers worried more about transportation logistics than availability. American soldiers could afford to be profligate with ammunition because more was always coming. The contrast in industrial philosophies revealed itself in combat. German soldiers with superior training and weapons ran out of ammunition. American soldiers with adequate training and weapons had unlimited ammunition. Soviet soldiers with variable training and reliable weapons also had sufficient ammunition. The tactical superiority of German forces couldn't overcome strategic material disadvantages. By autumn 1944, the ammunition crisis was affecting German operations across all fronts. In Italy, German defensive positions conserved ammunition for critical moments. In France, German forces couldn't sustain the fire support needed to stop Allied advances. On the Eastern Front, German artillery fell silent for hours or days, unable to answer Soviet bombardments. The infantry experienced the shortage most acutely. Riflemen and machine gunners, the soldiers who did the close quarters fighting that decided battles, found themselves rationing bullets. Orders came down to fire only when certain of a target. To use grenades sparingly. To save ammunition for defensive emergencies. These orders made tactical sense given the shortages but reduced combat effectiveness dramatically. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now and don't forget to subscribe.